Circles. Definition of a circle. Circle is a closed two-dimensional figure in which all the sets of points in the plane are equidistant from the center. In other words, what we're looking at here is my center. When I look at this right here, I'm circling it, and it's equidistant to every part of this line, from here to here to here, and that is called my radius. The definition of a circle is x minus h squared plus y minus k squared equals r squared, where the h is the x component for the center of the circle right here, the k is the y component right here, and in this case my x is 3. Let me erase this part. I made a bit of a mess so it's easy to understand. Let me go back to my pen here. And my x is 3 in this case. And I go 1, 2, 3. There's my x. My y is 2. So the formula is x minus 3 squared plus y minus 2 squared. And we're subtracting on these. If we go in the opposite direction, it'd be y plus 3, x plus 3, y plus 2. But we're subtracting it. So, and then the radius squared is 16. Well, this is 4 from the center to any point on this, or 2, 3, 4. That is the radius of 4. R squared is 16. Properties of the circle are, as I said before, the outer line of the circle is equidistant from the center, no matter where I'm touching it. If I have a diameter, that is the radius going from one side through the center to the other side. As a straight line cuts it into equal parts. Also the radii, this distance from the center to any point on the edge of the circle, are congruent, which means they're the same because they are equidistant from the center. Circles have different size radius and different radii, but they are similar. They're proportional to each other. And I'm talking about chords in a moment. And a chord, it's the largest chord. A chord is a line that cuts across from one side of the circle to the other. That goes through the center point. It is the largest one and has the diameter. The annulus is a larger ring and a smaller ring. The larger ring is my radius of r. The smaller ring is a smaller r. Two concentric circles that have the same center. Now, as I said a little while ago, components of the circle are an arc. An arc is the curved component of a circle. From here to here is the arc. Sector could be 2 radiuses. Now, the arc is in the outer edge. This is the sector, all this yellow right here. The sector is the area. The arc is the distance over the curve, but the sector is the area of that piece of pie. And then a segment is a line that goes from one edge of the circle to the other. It doesn't matter where it goes, but it connects 2 parts of the circle together. It does not have to contain the center. And the components of the circle, obviously the center, and a chord is a line segment whose endpoints lie in a circle. That could include a diameter or a chord itself. Diameter itself goes through the radius, both endpoints, the center of the circle. It is the largest chord there is. The radius is any line from the center of the circle to the edge. The secant is a straight line cutting through the circle. Now, the only difference between a chord and a secant is if we have arrows on each end of it, it's going to infinity both ends. The chord stops at the edge of the circle. The secant continues to go through. It just cuts through the circle. And then the tangent touches it at the infinitely small point where it's 90 degrees from any point of the radius or a diameter. That makes it tangent. If it's a tire, for example, going flat, straight on the ground, let's say this is a tire, The street is tangent to that. It's actually 90 degrees at that point where there's a perpendicular line going from where the tangent touching to the center. Radius of the circle, and this is circle O. Radius is considered R. Now, the circumference of a circle is the distance around the circle. The distance around the circle is actually found by the circumference formula, which is 2 times pi times r. 2 pi r, and this is the radius. And pi, it goes on infinitely, but it's basically 3.1415. So if I know the distance of the circumference that's constantly turning around the circle, what's that distance? I would take the radius, multiply times 2, and then times pi. And what is pi? Pi is the constant, never ends. It's how many radiuses does it take to go around a circle? Well, if I go halfway around a circle, I take one radius, and let's say it's a piece of yarn so I can bend it, and put it on the circumference. I take this radius here and put it, making it curve like a piece of line or yarn or rope. It will go that radius, regardless of the size of the circumference, 3.14 times around. Or in other words, halfway. To go from one side of the diameter to the other, it's 3 radiuses and a little bit more, 3.14. And then if I go another way around, I multiply that times 2, and that's where 2 comes in for 2 pi r. But the pi is considered what we multiply by the radius to see how far it is. Because on a circle, we're constantly making a turn, an infinitely small turn, but a turn nonetheless. So it comes back in on itself after 360 degrees, which we talk about in the coming day. Find the area and circumference of the circle. Now, the circumference, as I said, is 2 times pi times r. So the circumference is 2 times 3.14 in this case. We'll just make it 3.14 times 10, which is 62.8. Circumference of this one, I got 28 inches for the radius. It'd be 2 times 3.14 times 28. You multiply this out, 175.84 inches is the distance all around this circle. I'm not drawing the best circle here. From beginning back to the end, it has a radius of 25 inches. Now, we can do this in reverse. If the circumference is on a circle 314 meters, what's the radius? We put in our 314 for our C. We already know the circumference. 2 times 3.14 times r. R's are one known. So it'd be 314 times, right here, times 2 times 3.14 times r, which is 6.28 r. And I'm going to divide both sides with 6.28. And what I end up getting here is r. And 3.14 divided by 6.28 is 50. So the radius is 50 miles. 50 meters. Oh, it is 50 miles.